Hello, all. Hope you're doing well. So, we are going to discuss acid basis salts, which we were discussing before. So, this is lecture 5. So, in today's lecture, we are going to discuss about pH. So, this pH scale you might have studied in your lower grades also. So, it's an indicator when it comes to acids or bases or any kind of neutral substances. So, whether a substance is acidic, basic, neutral. So, the scale is going to help us indicate. Now, let's rewind. We did acid and bases. About acids classification, we discussed about bases classification, chemical and physical properties also. So, when we compare any kind of strengths of acids and bases according to Arrhenius theory, so we are not studying any other theory, just Arrhenius. So, we always say that any acid which has the capability to release H positive ion, more number of H positive ions, is a stronger acid, and less number of H positive ions is a weaker acid. That's a general, you can say, criteria. So, Arrhenius theory, it suggests that more the number of H positive ions released by an acid, obviously in the presence of water, stronger is the acid. So, same applies for base also. For OH number of ions also, it's the same concept. More the number of OH negative ions released by a base in water, stronger will be the base. Now, if we add a lot of water, if we have an acid and if we have a base, if we add too much of water, then we are talking about dilution over here. We have diluted this acid and base, right? So, this entirely will lead to dilution. So, what will happen if we have added too much of water? So, we can say the concentration or the number of H positive ions per unit area is going to decrease. So, after dilution, H positive and OH negative ions decreases per unit area. So, why I'm using this per unit area? Because the concentration is decreasing with respect to everything else. If you have acid, positive ions are there, then in this case of HCl is there, chloride ions will be there, then OH negative ions will also be there. So, when you add HCl and water has a capability to self ionize into H plus and OH negative ions. So HCl is also ionizing itself into H plus and Cl minus ion. So if this is getting changed into ion, so why not water? Water is not going to ionize itself just like that. If you have a glass of water in front of you, so it's not going to ionize just like that. It needs to have a separate component in order to ionize water. So if you remember the electrolytic decomposition of water, so it cannot happen on its own. You need to add few drops of sulfuric acid, which is a very good electrolyte. So it helps water to decompose into hydrogen and oxygen. So again, if we go into depth and we write the electrode reactions, anode and cathode, so then we will understand how hydrogen and oxygen is going to be released over there. So water cannot ionize, like until unless there is no other component. So self ionization of water is a very important concept, and it actually help us to understand that why you can say pH of water is 7, like why it is neutral, pure water if we say. So remember, if we add too much of water on dilution, now less water, more water, we have already done that in the past. Concentrated acid, concentrated base, dilute acid, dilute base. So addition of water will always decrease the concentration of H positive ions, obviously in the aqueous state, and OH negative ions in the aqueous state in acidic and basic solutions. Now, how can we judge this thing that if we have H positive and OH negative ions present in a solution, how strong an acid or a base is, like how to basically judge that? So we have this universal indicator, But universal indicator is a mixture of different kind of several indicators. It's not just one component. So it shows different colors at different concentration of H positive ions or pH values, right? So for calculating pH, there is a pH scale. Then we have a pH meter also, which is electrical, and you dip, you can say, like you have a pH meter, like I'm just showing in rough over here. So there is definitely an electrode, a glass electrode which is connected. So it's a electrode covered, like there is outer covering which is glass, and you just have to like put it in the solution. Like if you have, let's say, any soil added in water. Now if you go to different locations, soil nature, whether it's highly acidic or weakly acidic, or what kind of nature it is, whether it's near to neutral, or it's basic, or slightly acidic or not. So if we want to test that, so we will actually put this electrode, dip this into the solution over here, right? So that will ultimately give us, you can say, a value over here on the screen, and we will be able to see that gives us to the decimal of two digits, like let's say 3.54, something like that. So that's a pH value. We don't get this kind of value in pH scale. We can, by calculating for sure, but we have to apply log in that. Log is another mathematical tool. So the point over here is that, so we can calculate the pH. We can actually get the value whether the any kind of substance is very much acidic or basic with the help of pH scale. So I'm going to do the basic one, but yes, pH is a very large concept, and it is related to normality also, which is another concentration. About concentrations, again, I'll be covering in the separate video, but not in this video, or not in today's, because today, like, we still need to cover acid bases salts. So coming to the pH scale. So now coming to this scale, now we'll go back to somewhere in 1909. So it was, pH scale was given by Sorensen. Now most of the people use the surname only, but it's SPL's. Let's not. So Sorensen is a famous name for it's. He was a Danish chemist. Introduced the concept of measuring the concentration of hydrogen ions. So introduced the concept of measuring the concentration of hydrogen ions in aqueous solution. So P over here stands for potence, which is a German word meaning power. So we are talking about the power of, H stand for hydrogen. Power of hydrogen in any kind of solution. So pH scale, we know it varies from 0 to 14. So over here, let's say if we draw a scale from 0 to 14, here. Now, if we see, this is the 7, right? So this is near to like neutral. So if we go this way, the acidic character is increasing. And if we go this way, basic character is increasing. Right? And now if we want to, like, let's do one formula for pH. At least we'll have a basic understanding when I'll do that video later on. So before moving to that, let's write the ranges. So if we have a solution with a pH range of 0 to 3, 0 to 3 is strongly acidic. That's general. We are not doing in the decimal form right now. Now if we have 3 to 5, that is moderately acidic. Then if we go to 5 to 7, that is weakly acidic. So one way to remember this pH scale is, if you see the terminals. The terminals are always strong. If you're talking about the left hand side, less than 7, right? So it's strongly acidic. And then if you go to the another terminal, strongly basic. But if you talk about 7 over here, neutral. So near to 7, it's always going to be weaker. Weakly acidic, weakly basic. So I've written over here 5 to 7 is weakly acidic. 7 we know that is neutral. Then we go to pH with with a range of 7 to 9. This is weakly basic. 9 to 12, moderately basic. Then 12 to 14, strongly basic. 7 is neutral. Now we use this particular formula, pH is equal to minus log of H positive ion concentration. Now since I have not introduced the concentration, this concentration, technically we talk about normality, or we can even use molarity. The concentrations part, like I'll upload a different video so that you can understand. So now this formula, if we say, let's say any concentration if we have, so I'll try to make you understand over here so that we can understand, like, if we have acidic concentration, this is 10 raised to power 0, 10 raised to power minus 1, 10 raised to power minus 2, minus 3, minus 4, you go like that, minus 5, you'll understand in a minute, minus 7, minus 8, minus 9, minus 10, minus 11, 12, 13, and this is 14. Now what's the meaning of this? So I've written minus log of H positive ion concentration. So let's take an example. If I have minus log of, and the concentration I'll take it from here, 10 raised to power minus 3. Let's take this. So now we use a log formula over here. So logarithm is a mathematical tool. Over here we are, you can say, converting the pH, because concentration in any solution, whether it's H positive or OH negative ions, it's going to be very less. So minus 3 means what? 0.00001. That's what we are talking about. That is the H positive ion concentration. So even it is less, looking at it, it looks like it's less, but actually it's like too much. It's more. If we compare it with minus 14 means it's a very low number. Minus 14 means H positive ions are negligible. And do remember, you talk about acid or you talk about base, H positive ions, OH negative ions are always going to be present. It's always going to be lower concentration of H positive ion in your base, higher concentration of H positive ions or hydronium ions in your acid. It works like that. So if you compare minus 3 and minus 14, minus 3 is a bigger number. That means this particular solution will have more hydronium ions compared to minus 14. So over here, minus 3. So we use this formula of log. Log, we always use in chemistry. I'm not talking about maths, but in chemistry, we always take log base 10. So log 10 raised to the power x will be equal to x log 10. And log 10 value is equal to 1. It's always 1. So ultimately, log 10 raised to the power x is equal to x only. So let's say if I have this, we have taken minus log, right? So because we need to cancel out this minus 3, that's why we have taken minus over here. Otherwise, you can even write like this, 1 divided by log 10 raised to the power minus 3. So again, if this minus 3 will go above in the numerator, this will become plus. So minus, writing like this will be better. So now let's apply over here. So minus log 10 raised to the power minus 3. So our minus 3 over here is our x. So we will write, keep this minus outside the bracket. So this will be minus 3 log 10. If you can see. So log 10 raised to the power x is equal to x log 10. So log 10 value is always equal to 1. So ultimately this will be minus 3 and this log 10 is equal to 1 only. So this minus minus will become plus and this will be 3. So if you have a concentration of any acid 10 raised to the power minus 3, or even if it's given like this 0.001, convert it into like this so that you can apply in the numerical in the question over here. So ultimately, if you can see the chart now, minus 3 concentration means the pH value is 3, right? Minus 4 pH value is 4, minus 2 2, minus 1 1 over here. Now when you go to the base, then it's slightly different because then you have to subtract. So let's reverse. So if H positive ion concentration, what I have written over here, these are all hydronium ion concentration, right? Now if we are going to write OH negative ion concentration, so we will start from here. 10 raised to the power, this will be, if it is minus 14, so it will be 0. Then it will be minus 1, minus 2, minus 3. Then you reverse it. Now this again, like if we try to multiply, then we have to use another formula of log. Log, you can say x plus log y. Log, you can say not plus, into log y, log x so if we have log x into log y, or you can even write like this, log x into y, this will be nothing but log x plus log y. So if any value is getting multiplied, so ultimately it will be added up. So log values you have to see from the log table, or it can be given in the question also. Now if we have log x divided by y, now in that case it will be subtracted. Log x minus log y. So if it is multiplication, it will be added up. If it is division, then it will be subtracted, like that. So now coming back to this part, so we were doing over here 10 raised to the power minus 4, this is minus 5. So if you see over here, if we because we have to see the product also, I'll come to that part. So minus 6, minus 7, minus 8, minus 9, minus 10, minus 11, minus 12, 13, and this is 14. So what we are trying to understand over here, that if you see 10 raised to the power 0 is equal to 1, right? So you can say 0 is like very much highly acidic, so the OH negative ion concentration in that is 10 raised to the power minus 14. So 0 means it is huge concentration for hydronium ions. So now if we take the product of this, minus 1 into minus 13, that's how we try to understand for the self-ionization of water. So let's say water we have. So water changes into H plus and OH negative ion. So let's say we are going to write an equilibrium constant. So the equilibrium constant over here that we are going to write, that is according to the law of mass action. So according to law of mass action, how do we write it? It's like whatever concentration for H positive ion we have, whatever concentration we have for OH negative ion. Specifically with respect to pH, we always write the concentration in brackets. Since I'm not talking about the how to calculate the concentration, because in these questions it will be either given in the question. So according to this law of mass action, what do we write? We write the equilibrium constant given by symbol K. So we say concentration of products divided by concentration of reactants, or we can actually say product product of concentration of reactants, product of concentration of products over here. So what's the meaning of this? So H positive ion concentration, this which is our product, so it needs to be multiplied. So that product we are talking about multiplication into OH negative ion divided by reactants that we have is over water, right? So let's say this K will be multiplied with the water concentration, and that is equal to H positive ion concentration, OH negative ion concentration. Now over here, since we have done this, so new equilibrium constant, so we call it as ionic product of water, KW. W stand for water. So this is a new equilibrium constant over here, which is introduced when we multiplied the concentration of water into the equilibrium constant over here. So new equilibrium constant. See, equilibrium is a state. I have already discussed this reversible sign. So equilibrium is a state, you can say, when your reactants are changing. It's a dynamic equilibrium. Reactants are changing into products, H positive, OH negative ions. At the same time, these products are also changing back into reactants. So it's you can say it's a reversible process happening. So after a certain period of time, they are going to maintain some equilibrium, right? Equilibrium, a state where there is no change happening. So now over here, this is going to be equal to H positive into OH negative ion. Now since we are talking about water, if you see the scale over here, this particular scale, -7 and this -7, can you see? For hydronium ion as well as for OH negative ion concentration, if we have taken water, both are having the same concentration. So we are going to write 10 raised to the power -7 for H positive ion and 10 raised to the power -7 for OH negative ion, and this is equal to Kw. So when you are going to multiply it, so obviously it will be added up. So this will be equal to 10 raised to the power -14, which is Kw. Now if you apply log, the same formula on it, so we can say you can say this can change into 14, the ionic product, right? So if we apply log over here, so now coming back to this part, so everywhere the ionic product of water, or you can say any solution, they are trying to maintain 14. So -4 into -10, right? If you multiply, it will be always 14. -12 into -2, this is again 14. -10 into -4, 14 again. -2 into -12, 14 again. So if you see the product, ionic product of water indicates that you take any solution, whether it's acid or basic. So it will always maintain its ionic product. The concentration of H positive or hydronium ions or OH negative ions are always going to be same. They try to maintain that. So either there is an increase in H positive ion concentration, at the same time there will be some decrease in the OH negative ion concentration. Similarly, if there is a decrease in H positive ion concentration, there will be increase in the OH negative ion concentration, just to maintain the product over here, that is 10 to the power -14. So rest I'll be talking about pH, this numerical part again in separate video. So we'll move ahead to the applications of pH. So in applications, before starting, just we need to know few, you can say, pH values of different substances that we have in daily life. Like coffee, if we say, that is acidic, then even tea is also acidic, lemon juice is acidic. So we have our saliva, that is basic. So the values you can remember if you want to. Like somewhere around 7.4 we have saliva, that is before meal. After meal, saliva is going to be acidic, somewhere around 5.8, right? So there are certain values given, again they have calculated based on different parameters. So importance of pH in everyday life, why you can say this pH is so important to us, and why do we check pH of most of the things in our daily life. Like I'll take an example. One of the you can say experiment, or not experiment, I would say internship I was doing. So that was checking soils of different locations. So that's what I was discussing about with the pH meter. So we used to check the pH of the soil by adding in water, and then checking its pH with the pH meter, because pH meter always gives you better values compared to any other method. So now after that, we can start with like in digestive system. So we know that our stomach produces gastric juice, which contains large amount of hydrochloric acid. So HCl, gastric juice, so its pH value is around 1.4. So acid which is produced, it is not going to harm our stomach walls, but it kills any kind of bacteria, germs which are entering into our digestive system. So it gets killed over there in the strong acid. So it protects us from various diseases, from any kind of and helps in digestion also, right? But sometimes what happens, right, if due to overeating or even less eating spicy food, so that leads to acidity, right? So that is like when our stomach lining has released a lot of acid and we feel indigestion or acidity. So in that case, what do? We use antacids, right? Antacids are nothing but they are going to neutralize the excess acid, like magnesium hydroxide. If I've used this term milk of magnesia, MgOH whole twice before also, so that can be used over there. Then we have plants and animals, so they are also very much pH sensitive. So our if we talk about pH of human body, so that is around 7 to 7.8, right? So if we say fishes in the you can say river water or ocean sea, so they also can survive in a narrow range of pH only, so slightly acidic that can even kill them. Same goes for the plants also. So rainwater, if we say rainwater pH, you can say it is somewhere less than 5.6. So if it is less than 5.6, that rain is called as acid rain, but if it is higher, that means it's fine rain, like it is okay. So now the same rain, if it is you can say it's released into the river or any river body, so obviously its pH also will be impacted. Similarly, soil pH will be impacted. So it's a whole chain. Then coming to soil pH. So soil, usually we need to have a pH of in the basic range. We never need any kind of soil which is acidic. If it is acidic, then we need to do something about it. We need to add some substances just to neutralize it or just to make it basic. So growth of plants in a particular soil is very much related to pH. We have certain plants, now that is slightly biological, but yes, plants do exist which can even survive in extreme acidic conditions. You can search about it, they can. So, but on a general trend, on a general scale, it's always going to be basic. So, it's important. If it is too acidic, then we need to add some basic compounds like lime is there, calcium oxide is there. So, we can add, you can say, in the soil so that it can improve the plant growth. Then we have tooth decay. So pH in the mouth, it's you can say if it is more than 7, then the saliva produced is very much basic. But if it is less than, you can say 7, or it's very low, 5.5, even below that, that leads to corrosion of the enamel layer which is on the tooth, right? So if we talk about our tooth, majorly is made from calcium phosphate, Ca3PO4, whole twice. So this calcium phosphate will start reacting to the acids which are released through the saliva. Definitely leads to degradation of the enamel, which is protecting us in return. So this coating will be broken down and ultimately cavities can happen. That's why we always use toothpaste. So just to clean the mouth, which is basic in nature, and it removes any kind of excess acid and prevent tooth decay. It doesn't prevent always, but yes, you can say like most of the time, yes, it is a protective remedy. Then we have Self defense in plants and animal. So, what do you mean by self defense? Now, many plants can release some kind of acid if we try to touch them. So most of the herbaceous plants which are growing in wild, right? So you can say nettle plant is there. So nettle plant has a stinging, you can say, hair. So if we try to touch it, so it releases methanoic acid, HCOH. So that can inject, you can say, in our skin. So we can actually, like, it's a weak acid, but still it can just causes burning sensation, right? So we can actually repair it with the help of baking soda. Baking soda is nothing but sodium bicarbonate, commonly we call it as baking soda. So then, like honeybee sting is there. That also contains the same formic acid, so it causes a lot of irritation and pain. So again, we can use baking soda. We should not directly add base to it, because bases, some of the bases, specifically sodium hydroxide in the concentrated form, is also corrosive to a certain extent. So salts, which are basic in nature, will be always beneficial. So next lecture we'll be discussing about salts only. So I hope this video was helpful. So thank you for listening, and please like, subscribe, and share my channel, for so that all these videos which I have on my channel can be reached to maximum students, and it should be helpful. Thank you.